brain dump for the 7th grade math. What's the first thing we're going to put here?
Dorito Man.
Dorito Man. Now I want you to write out Dorito Man. Okay? Because what does Dorito Man help teach us?
Division.
Yes, ma'am?
Multiplication.
Okay, so it's for division and multiplication. All right, so the name is instructive itself. It tells me I only use this for division and multiplication. Now, how does Dorito Man work? What if I'm doing a negative times a positive? What do? Yes, ma'am?
You cover up the negative and a positive, and then you have negative.
Okay, whatever you have left here is what the sign of the answer is going to be. So what if I'm multiplying or dividing two negatives? What's my answer going to be?
A positive.
It's going to be a positive, right? Now, these rules only apply when I'm doing what?
Multiplication.
Dividing or multiplying. So for my other rules, like whenever I'm adding or subtracting integers, okay, there's two things over here I have to consider, two rules over here I have to think about. What's the first option here that we have to think about? Yes, ma'am?
Wait, I'm thinking.
My mind's a blank. I had it.
Okay, yes, sir?
Keeping the sign.
Okay, so if they have the same signs. Okay, if they have the same signs, what do? You add them up, and you keep that sign, right? I mean, it's just obviously, you add them, you keep whatever sign it is. Okay, what's the other possibility we need to consider? Yes, ma'am?
If they have different signs, you need to subtract and keep the sign of the one.
Okay, good. So the other option is if they have different signs. In that case, we're going to subtract them and keep the sign of the larger. Keep the sign of the larger one with the larger absolute value. So these rules are very, very important because they show up in so many different things. You have to know how to deal with your signs. If you're dividing or multiplying, use the Dorito Man rules. If you're adding or subtracting integers, you're going to use these rules. All right. In our top thing here, what are we talking about in the first line here? Slope-intercept form. What is the capital, or not the capital, I'm sorry, what does the M stand for?
Slope.
Stands for slope. What's another phrase that they might ask that would be asking for the same thing? Okay, and I'm not asking like how to find slope. We'll talk about that in a second, but there's another phrase that they use a lot of times. Yes, ma'am?
Rate of change.
Good, is rate of change. Okay, so if in a question they ask you for the rate of change, they're asking for the slope. And we'll talk more about slope in just a second. Okay, what does this B stand for? What does the B stand for? Yes, ma'am?
Y-intercept.
Stands for y-intercept. All right, I want you to draw a quick little XY here. Okay, what kind of line is this? What do we call this kind of line? Yes, sir?
Horizontal.
Is a horizontal. Yep, and so what axis is this one?
X.
Is the X. Okay, and obviously this is the Y. So what I want you to do now is I want you to draw a line like this. And the y-intercept is this point right here. Okay, the y-intercept is where that line crosses the y-axis. All right, I want you to draw a slope face up here real quick. Okay, looks like you're all getting that down good. A lot of you already had it drawn, that's good. Okay, so when a line is going uphill like this, what kind of slope does it have? Positive slope. When it's going downhill, what kind of slope? Negative. And again, for 7th grade, y'all probably don't have to worry about these other two, but you're going to have to start thinking about it next year, and so the slope face is good just to start thinking about now. But if a line's going straight up and down, what kind of slope does it have?
A
Good. This is like a U for undefined. And if a line's going straight across, what kind of slope is it?
0.
It's a slope of 0. No slope, okay? Now, this line that I drew down here, what kind of slope does this have?
Negative.
It's negative slope. It's going downhill. So this is like this eyebrow here. It's negative slope. All right, let's go over here. All right, how do we find, or again, what does the M stand for? What does the M stand for? Slope. How do we find slope?
The rate of change.
Okay, rate of change, that's another phrase they would ask. But how do we find the slope?
Rise over run.
Is rise over run, there you go. And remember, the top number tells us how far up or down we go. And the bottom number tells us how far to the right we go. It's just the way we count it. We always start at the left hand point, the point further to the left, and count our way to the point on further to the right. And up and down is where our negative or positive will come in. If it's going up, it's positive. If it's going down from left to right, then it's negative. Okay, so that's how we find the slope. How do we find the B, the y-intercept? And it's not necessarily like we're plugging in numbers or anything like that. Just in general, how do you find the y-intercept? Yes, ma'am?
Where the line crosses the y.
Yeah, you just look for the place where the line crosses the y. Okay? So to find the B, look for where the line crosses the y. So to find the B, all you have to do is look and see where it crosses the y-axis. Okay, and the B is like the starting point. It's the beginning point. You can think of B as beginning. It's the beginning point. It's like where you start from. And then from there, it may increase or decrease depending on the slope. But the B is the y-intercept where it crosses that y-axis. That's all you got to do is find where it crosses there. Okay, for constant proportionality, I want you to make a quick little X, Y, T chart here. And let's go 2, 6, 3, 9, 4, 12. 2, 6, 3, 9, 4, 12. What letter do they use to find the constant proportionality? Or what letter do they use to represent that? Yes, ma'am?
K.
Is K. All right? Now, to find K, what do you do? Y over X. So I'll go over here, find any of these pair. I'm just going to choose the top one. What's the Y value? 6 over what's its X value? 2. What's 6 divided by 2? 3. So what is the constant of proportionality for this thing? Is 3. Okay, what does circumference mean? What is circumference? Yes, ma'am? Yeah, it's the perimeter of a circle. What's the other way and I like that. That's good. But what's the other way we describe this? Yes, ma'am?
Distance around the circle.
Okay, it's distance around the circle. Okay, it's the distance around the circle. It's not the inside. It's just how far it is to go around the outside of a circle. Which, that's right, we talked about this also. It's like the perimeter of the circle. Okay, what does this variable stand for? Yes, ma'am?
The radius.
Radius. What does this variable stand for? Yes, ma'am?
Diameter.
Is diameter. Why are these two formulas the same formula? Why are these two formulas the same thing? Yes, sir? Exactly, because 2 R's equals 1 D. It takes 2 radii, 2 radiuses, to make 1 diameter, because the radius only goes halfway. So that's why this and this are the same thing, is because 2 R's is equal to 1 of these. Okay, I want you to draw a circle. Let's go halfway. What is this? Yes, ma'am? It's the radius. Let's draw another circle. What is this when it goes all the way across? Yes, ma'am? Diameter. What's one way we can help to remember that? Yes, ma'am?
Is that when you cover up one side, it makes
Okay, if I cover up this side, notice how when this line goes all the way across, what letter does this make? A D to remind you of what?
diameter.
The diameter, okay? So we have the diameter. Okay, makes that. All right, for a triangle, let's draw a couple of these real quick. So a triangle, this would be the base, this would be the height. How do we know what we need to use for the base and the height on the triangle? Yes, ma'am?
The base is the very bottom shape, and then the height is going straight down.
Yes, it's the two sides that are 90 degrees to each other like this. That's right. Going straight across and then going straight up and down. All right, so on triangle like this would be the base, and then going up to the tallest point is the height. Okay, when you're taking your test and you need to use a formula, should you trust your memory?
No.
Do not trust your memory. You can say to yourself, you can say, self, I know what this is, and the other person inside says, I know you do, you're so smart, I know you know this. And you're like, but let's just go over and go check and make sure that that's exactly right. And go over and look at the formula on the page and make sure, don't trust your memory, okay? I know your memory is important, but I don't. In this case, don't trust it. Go over and look at it, and don't just go over there and just quickly look at it. Make sure you stop, because when you're taking the test, your mind is like, sometimes it's just like going crazy, and like you may look at it and think you know what it says and just quickly look away. Make sure you stop and actually look at what the formula is, and make sure that's actually registering in your mind. So make sure you look at it and that you're actually looking at the formula and that you write it down. Because for triangles, I don't know why, so many people forget to divide by 2 with the triangle. Because on a triangle, what does it say the formula is right here? Yes, ma'am?
1/2 times base times height.
1/2 times base times height, but what's the way that we normally do that?
Base times height divided by 2.
Base times height divided by 2. So often people forget to divide by 2 on the triangles. I don't know why, but it's just a very common mistake. So make sure if you need to use a formula, go look at your formula chart. Do not trust your memory. All right, for a rectangle, this is the base, this is the height. For a parallelogram, this is the base, and this is the height. If they give you the length of this slanted side right here, are you going to use that for your height? No. That's like if I take a tape measure from the top of my head, and instead of going straight down, I take it at an angle going way over there somewhere, and I'm 9 foot tall. Is that the way I should measure how tall I am? No. You do not measure your height going at an angle like this. You measure your height going from straight up and down to the tallest point. So make sure whenever you're using for the height, it's going straight up and down. Do not use this slanted one for the height. That's just weird. You would never do that, okay? Doesn't make sense. Okay, for a trapezoid, how do you know what is B1 and B2? Yes, sir? The two sides that are parallel to each other. So you could have a trapezoid, whoops. You could have a trapezoid like this. And it's not drawn very well. I need a piece of paper underneath here. So this is base 1 and this is base 2. Because these are the two sides that are parallel to each other. But they could take it and turn it like this. And now this is your base 1 and this is your base 2. Your base 1 and base 2 are the two sides that are parallel to each other. And then this would be the height here. And then in this case, this would be the height here. And in this case, it's just like what we talked about. You know, the height is the distance between the bases, right? So on this one, the height is here, and it's because this thing is laying on its side. Okay, for a circle, to find the area, we need this. So if you have a circle like this, 10 inches, am I going to plug in 10 for this right here? No, why not? Yes, ma'am?
Because it says pi times the radius squared.
Uh-huh.
So we would have to divide 10 by 2 to get half of it, and that would be great.
Okay, good. So what is the 10 here?
The diameter.
It's the diameter. So on this one, the diameter is that, and the radius is what? 5. So I'd have to plug in 5 here. So it'd be pi times 5 squared. Be careful. They will do that. For the area of a circle, you have to have the radius. So you're going to take that diameter, cut it by 2. Now, what is 5 squared? Yes, ma'am?
5 times 5.
It means 5 times 5. And so what is that? 25. So 5 squared means 25. 5 squared means 5 times 5. It does not mean 5 times 2. That would be 10, and that's wrong. 5 squared means 5 times 5, which is 25. All right? What is one way we can tell the difference between a prism and a pyramid? What's one way we can tell the difference? Yes, sir? Okay, tell me what it is. What's the difference between a prism and a pyramid? You're right. The main way we're going to check is by its bases. Or, yeah. Okay, yes, ma'am?
The prism has 2 bases and the pyramid has 1.
Okay, good. A prism has 2 bases and a pyramid has 1 base. Prism has 2 bases and a pyramid has 1 base. Now, what do they use to name a figure by? What do they use to name a figure by? Okay, yes, sir?
The shape of its base.
Okay, good. So the name of a figure is based on its base. Okay? The name of a figure is based on its base. The name of a figure is based on its base. Like, for instance, a triangular prism. What shape is the base of a triangular prism? Yes, ma'am? Is a triangle, okay? What is the shape of the base of a rectangular pyramid? Yes, ma'am?
Rectangle.
A rectangle, it's that easy. The name tells you what the bases are, okay? Now, in the formula, what does the capital B stand for? What does the capital B stand for? Yes, sir? It stands for area of the base. And how do you know what the base is? How do you know what the base of the figure is? Yes, ma'am?
Wait, what did you ask me?
How do we know what the base of a figure is? Yes, sir?
Length times width.
Well, no. How do I know what the base is? Yes, ma'am?
By its name.
Yes, by its name. That's how you know what the base is, by its name, right? Okay. Okay, pi is approximately equal to 3.14. So if you see any problems that ask you, is like, well, what up in this problem will give you pi? A lot of times they try to make those as confusing as possible, but all you care about is whether the 2 numbers divided give you 3.14. That's what you're looking for on those. Do these 2 numbers divided give me pi? And that's what I'm looking for. Okay, you will not need the compound interest. You might need the simple interest. So let's talk about these 3 things real quick. P, R, and T. What does the capital P stand for? Yes, ma'am?
Principal.
Stands for principal. And this is not like principal, like a person, like the principal of your school. This is the principal like the initial amount. Okay, like if you buy a boat for $10,000, $10,000 would be the principal. Okay, what is the R?
Right.
Rate. And what do we have to remember to do to the rates? Yes, ma'am?
Something to change.
Okay, you got to do something? Yes, sir? You have to Dr. Pepper it. You have to Dr. Pepper it, right? Like, for instance, what I mean by that is this is 15% Dr. Peppered. We have to move the decimal because we're taking it from a percent to a decimal. And so what is 15% Dr. Peppered? Yes, ma'am?
It's 0.15.
It's 0.15, exactly. Right, because you got to move the decimal 2 places. So with the rate, you have to Dr. Pepper it. And then what does the T stand for? What does the T stand for? Yes, ma'am? Stands for time. And so if you're looking for simple interest, you just multiply those three things. The principal times the rate, Dr. Peppered, and times the time. Okay, let's flip it over and talk about a little bit of conversion stuff real quick. Just a couple things here real quick. So for converting within the metric system, what's the little thing that we use to help us remember that? Yes, ma'am?
King Henry died unexpectedly drinking chocolate.
King Henry died unexpectedly drinking chocolate milk. This is converting within the metric system. So kilo, hecta, deca, the base unit, deci, centi, and milli. So if they tell you something in milli and you want to find it in kilo, you have to start here, move the decimal that many times. Okay, and that's how many times you have to move it in the number. Okay, let's jump up here to this real quick. Let's say something is 5,280 feet, and we want to know what that is in miles. So what I'm going to do is I'm going to look for my conversion here, and I see at this first line, 1 mile equals this. So what I'm going to do is I'm going to say miles. I'm going to set up a ratio here, miles to yards. So from my conversion, 1 mile is 1760. And here this 5,280, is this the number of miles or the number of, oh, I meant feet. No, I meant to put yards up here. I'm sorry, this should have been yards up here. I'm sorry. Should have been yards up here. Okay, so this 5,280, is this miles or yards? It's yards. So I'm going to put it down here with the yards, and I'm looking for the number of miles up here. Okay, we would cross multiply and solve here. 1760x equals 5280. And we're not going to actually do the math, but x equals 3 there. It'd be 3 miles.